Hello again. We're back here in statistics. I'm Mrs. Puentes. As you know, we're over midterms now. We're finished with chapter 7, and hopefully you're getting the swing of shading under the curve, area under the curve, and finding the probability. And always remember the total area under that curve in chapter 7 was 1, and half the curve, of course, would be 0.5. Now, in chapter 7, we did everything with population data. Well, in statistics, we very, very rarely will take the population data for statistics. We always take a sample. That's why it's called statistics. And we estimate the population based on that. So for the rest of the semester, we are actually going to take just samples. Now, I hope you have your 3-page formula sheet. I hope you have now printed out the Z table and the Z and T flow chart. I will show you those as I lecture today. The first item I want to go over with in chapter 8 is the central limit theorem. And throughout this chapter, you will need your handout, but I'm going to give you bits and pieces of the handout, not the entire handout. I will let you look at my PowerPoint presentations for some of the problems. But the central limit theorem tells us that no matter what distribution we start with in the population, and I think this will be a good time to go over to the .cam. So if we have, for example, population data, and we graph the individual data points, let's say this is salary. Typically, salary is a skewed distribution, so therefore we cannot use the Z table, okay? If we take, and this is maybe the entire population here of Hudson Valley salaries. If I take a sample of, let's say, 30 employees, and I plot those averages of 30, and I take another average of 30 employees, and another average of 30, and another average of 30 employees, and I'm plotting them, and another, and another, and another, those averages will be normally distributed. This is a sample. These average salaries will be a sample. The central limit theorem, and I want you to read in the book and write it down on your handout, states that for a population, if we take a large enough sample, and 30 or larger is a good size, a skewed distribution will be a normal distribution if we plot the averages. And therefore, we can use the Z table on that. So the entire chapter is based on that premise. So I want you to be sure you understand the central limit theorem. Okay? Because we are using the sample, we no longer will use this formula. In fact, on your chart, just put an X through it because students get confused. Now we are going to calculate Z based on an average, population mean, and there's our denominator, standard deviation divided by the square root of n. This is very important. It's so important it has its own name. It's called the standard error of the mean. We're talking about mean data. We're going to talk about maybe seconds or money or ounces of soda in one of the examples, okay, or pounds per square inch to break a paper bag, or a couple of the examples we're going to use in chapter 8. But this is important. It's called the standard error of the mean. And that's on your handout. So the standard error of the mean, right here. Okay. Now what I'd like to do, here is your handout. By the way, all of these symbols and their definitions are on your 3-page handout, your 3-page formula sheet. It's a little smaller print, but right up there at the top, so you'll want to have that. Okay. So we use the Z statistic when we have the population standard deviation and a large sample size. Okay. There's the standard error. So let's go to our first example, and I hope you have it in front of you because I can see that the print is awful small on here, but hopefully you have your handout right in front of you. I will read it. A normal population has a mean of 75, a standard deviation of 5. You select a sample of 40. Compute the probability that the sample mean is less than 74. Okay, so we know the population and this population mean and population standard deviation. Mu is 75 because we've making this part for years and years and years. But we're going to select a sample of 40, n equals 40, and we want to know, is it less than 74? Well, our first step now is to calculate the standard error. 5 over the square root of 40, and that equals 0.7905. Okay? Standard error now. No more just standard deviation. We've written our givens. Next step is to draw our normal distribution. We found out our mean, our population mean is 75, less than 74. 74 is to the left of 75. Where do we shade? Less than 74. This will be our answer. But remember, our Z table was designed to calculate the percent area of the curve from the center line out. So that's what we're going to do. We have Z, and there's our Z formula. We have 74 now is the average of those 40 samples, minus 75 over, I am just going to use the standard error now instead of the entire formula since I calculated it. When I do that calculation, I get a Z of 1.26 approximately. I look it up in my Z table. You should be very comfortable now looking it up in your Z table. 1.26. 1.26 is a probability of 0.3962. That is between 74 and 75. This area right here, 0.3962. That doesn't answer our question. What do we have to do? We subtract it from 0.5 because half the curve is 0.5. If half the curve is 0.5, we know this area between 74 and 75 is 3962, and that will give us 0.1038. This area, the answer to our problem is 0.1038. Okay? Our first problem. Our second question, between 74 and 76. So we draw a curve between 74 and 76. Well, we've already calculated between 74 and 75. That is 0.3962. Now we have to just calculate, this is going to be our answer, this area plus that area. So let's calculate between 75 and 76. Standard error goes in the denominator now. And again, it's 1.26. We looked that up. It's 3962. Plus the between 75 and 74 was also 3962. And when we add those up, 7924 total. Now, if you're getting good understanding of this symmetry, there's one data point between 74 and 75 and one data point between 75 and 76. So you really didn't have to do the calculation. If this is 0.3962, this is 0.3962. But if you want to double check yourself, you can calculate, you can do the calculation. Now the next one between 76, see, between 76 and 77, that's the hard one. Let's draw the curve. 75 is our mean, but 76 to 77. We shade, we want to know between these, so this is where we shade. That's our answer. Well, we don't have that yet. We do know 75 to 76 is 0.3962, right here, this area. And we also know our z-table is designed from the center line out, so we have to calculate 75 to 79. We have to calculate this area, z, 77 minus 75 over the standard error, remember, not standard deviation. When we do that, we get 2.53. We look that up in the table and we get 0.4943. You should be looking these up in the table. Check me. I do make mistakes. So this area is 0.4. From here to here is 0.4943. From here to here is 3962. We want this area, so we subtract the two of them. Get 0.0981 for answer C. D, greater than 77. That would be this area. Well, now we know between 75 and 77 again is what? 0.4943. We know half the curve is 0.5. So in order to get the tails, and I've mentioned this, whenever you calculate want the tail as the answer, subtract it from 0.5. Okay. So this is very similar to what we've been doing in Chapter 7. However, I can't emphasize enough that we're using the standard error now that we're sampling. You have to remember to use the standard error, not the standard deviation, in all of these calculations. I'm going to let you, on your free time, do the Coca-Cola example that I have on my PowerPoint presentation. It's a little challenging, but it really is very similar to what manufacturing environment does. Okay? And in this chapter, you don't have to look at the t statistic too much. I will tell you what happens with the t statistic is sometimes we have a sample standard deviation, which is S, and we have a small sample size, and that is the sample size is less than or equal to 30. When those two situations arise, we have to use the t-table. The t-table, if you go, it's on the back side or the second page of your tables. We're not going to do problems in this chapter. You can go ahead to chapter 9 and start reading about the t-table, but I like to just expose you to the t-table right now without problems. You might want to shut the camera, shut this off right now, or pause it and go do the problems that I suggested, or go through my PowerPoint. Now I'd like to continue. There's another type of data that we use for when we use the Z statistic, and that is called when we use proportion data. Proportion data are percents. We have to use entirely different formulas for proportion data. And I hope by this time you printed out my table here. If you notice this last column of data, it's all about proportions. Okay? We use a whole set of different formulas for proportion. For example, here's the standard error. Standard error for mean data, but here's the formula for standard error for proportion data. Here's the formula to find the area of under the curve that we're going to use right now. But you'll notice the denominator is the standard error of the proportion. What you can always remember with proportion data, sometimes you're going to start reading problems and you can't remember to use the mean data formula, or the proportion data. Here's a little hint. I do not give you standard deviation when we use proportion data. We don't need it. Notice there's no standard deviation. Right here, I say the standard deviation of the population of the sample is not given. So if you don't, in a problem, if you don't see the standard deviation, it's probably a proportion. So keep that in the back of your mind during the test. Okay? So let's go back to our problem. I do also want to mention that I gave you additional problems for proportion data. There's not a whole lot of proportion problems in the textbook, so you can find additional problems either on your the last page of your homework sheet, or it's the last page of your handout. So let's go on to using the Z statistic for proportion data. First thing I want you to remember is the standard error. Standard error of the proportion is the population percent times 1 minus the population percent divided by sample size. The entire calculation is under the radical. Remember that. That's one of the biggest errors. Some students don't ask me why I only put the numerator. That's the standard error. It's down here in the denominator, just like the other problem. Now, very often with proportion data, and this has happened to us before, we have to calculate the sample. I might give you the population. Let's say I know in my statistics class that the population that gets an A is 8%. However, I sampled my hybrid class, and by the way, the symbol for sample population is either a lowercase p or PS. I sampled 30, and I found out 3 got A's, or 10% got A's. So sometimes you are going to, very often you're going to have to calculate the sample proportion, remember that. And I will always give you the population percent. Okay? So let's go on to the problem. In this problem, I did give you the sample. Again, I hope you have the handout. The writing is pretty small on this. So, example, assume it is known 76% of the people in the U.S. have health care. Well, that means the population percent is 76. Always put it in decimal form. Always. What percent or proportion of the samples fall between 76 and 78? So my sample is 78. We take a sample size of 50. Well, the first thing we're going to calculate is the standard error of the proportion. Which of these proportions do we use? We use the population. We use the population in this calculation only. Whoops. So we have 76 times 1 minus 76 divided by 50. So the standard error of the proportion is 0.0604. Now let's go to the problem. We draw the curve just like we do, just like we do with mean data. Our population mean is right here, 76%. We want to know between 76 and 78%. In other words, if I go out there, and I said in between, there's my answer. If I go out there and I sample 50 people, I would like to know what's the probability between 76 and 78% will have health care. So here's the formula. Again, this is the standard error. You'll notice in the formula, and I want to emphasize this, the population percent is used in 1, 2, 3 places. The sample percent is only used in 1. So let's see. The sample is 78 minus the population. Now the standard error I already calculated, so I'm not going to calculate it again. That's one of the advantages of calculating it ahead. And I got a z-value of 0.331. That's not the percent, remember? You need to look that up in the table, and you get 0.1293. That is the percent for right there. Okay? That answers the percent between 76 and 78%. Now, I believe on the PowerPoint presentation, it says there's also a B part that says greater than 78%. Well, if I draw, if I draw the curve, 76, 78, greater, I know this is 1293, this is 0.5, I just subtract 0.5 minus 1293, and I get 0.3707. I also ask, how about greater than 76%? Greater than 76%. Well, guess what? You should be good at this. That's 50%. Okay? Now you can also do things like create a 95% interval, and I believe on the PowerPoint presentation we've done that. %, confidence, 95% interval. This is going to be 95, so this is 95 divided by 2, or this is a percent. In other words, I'm looking for the 95% interval for these two proportions. So we're going to call this one 1 and 2 to just keep them separate. I gave you the percent, so you are going to look for the percent in the center of the table and come out and give me the z. So if I look at this, the z associated with this is 1.96. It's on the left side. So it's negative 1.96, and this is a positive 1.96. Okay? So I will calculate P1. Here's Z equals P1 I'm going to put in the formula. The population is 76, and the standard error is here. On this side, I have a positive 1.96, P2 minus 0.76, 0604. And I'm going to leave it up to you to do that algebra, to calculate P1 and P2, and I believe you can check it on my PowerPoint presentation. So this concludes Chapter 8 on finding the area under the curve. I have exposed you to the standard error of both with Z data and proportion data. Okay? You need to do your homework. If you have any problems whatsoever, email me, stop by my office, and I can help you. On our next chapter, we're going to use these similar formulas, and we're going to calculate confidence intervals. Do your homework. Come and see me if you need help, and have a good day. Thank you.